Okay, here's a second video on these reflections and translations. The notes are going to be online too, so you don't have to watch the video. You could just access the notes. But if any of these elements are you're kind of unclear on, even if it's a different method, it might be good to check in with your teacher to say like, hey, I'm not quite so sure on how you visualize that. Tell me how to go through it, because there are several different ways to access graphing a transformation of a function. I said I'd do this one. Use this graph to answer the following questions. We have done a lot of looking at the equations and finding out the graph. We haven't gone the opposite direction. Here's the graph, what's the equation? So here's how to analyze that. First, identify what the parent function is. Your choices are linear, quadratic, cube root, square root, cubic, and absolute value. This one has this kind of a pattern that started by being a cubic. But what's happened to it? Since it looks originally like this, going from bottom left to top right, it looks like it has been reflected over the x-axis. It could actually be the y-axis too. Either way, we'll do both of them. It's been reflected over, let's say, x-axis, or we could say or y. And then it used to be at 0, 0, but now that important point, kind of the pivot point where it goes from up like a cup to down like a frown, is at 1, 5. So we've gone right 1 and up 5. So we want our graph, I'll call it g of x, to mirror that, or I guess to show that we've had a reflection and then right 1 up 5. I'm going to start with the bare bones. I know that it's going to be a cubic, so something is going to be cubed in there. And something is going to be reflected over the x-axis, so I'm going to put this negative sign on the outside of the function. Since that tells me that it's the y coordinates are flipping, I'm reflecting over the x-axis. Right 1 up 5. I want it to go right 1, so that actually means I'm going to subtract 1 on the inside of the argument and then up 5. Negative x minus 1 cubed plus 5. It's always good to double check to see if you've got some points that work in there. So for example, it looks like 0, 6 is one of the points on there. Does 0, 6 work in this negative? 0 is negative 1 cubed plus 5. That actually means that's negative 1. Opposite of that is 1 plus 5, and that's 6. It works. You could also try, it looks like the point 2, 4, and others. Let's see, I told you I'd show you the other way to do this one. If it was reflected over the y-axis, I believe that then that negative 1 could be in there. So I believe it could also be, I'm going to put brackets around it, negative 1, x minus 1 cubed plus 5. This is still a cubic. It's been shifted right 1 up 5, and now on that inside it has been reflected over the y-axis. On this one, this cubic function, it doesn't really matter. But something like the quadratic and absolute value reflecting over x is different than reflecting over y. Okay, next one is going to be, I think I wanted to show you how to go through and think about this new function. I've taken the square root. I'm going to reflect over the y-axis and then right 1 up 3. You can use a table. You can also take points and kind of run them through this sequence. So I'm going to take the point 0, 0, which is on my original. I'm going to reflect over the y-axis. That doesn't change it a bit. I'm going to go right 1 and up 3. Put it there at 1, 3. I'm going to take my second important point on the original square root function, 1, 1, reflect it over the y-axis. So it goes down here, then right 1 and then up 3. looks like that. Wait a second. Oh, wait, I'm reflecting over the wrong axis. My bad, my bad. Doo, doo, doo. I should be going right 1 up 3 takes me here. And reflecting over the y-axis means I'm going over here. And right 1 up 3 puts me at 0, 4. If I take now this point 4, 2, reflect it over the y-axis, I use the y-axis as kind of a mirror, so that means I'm over here, and I go right 1 and up 3. That puts me at the point -3, 5. And then this final point, which is at 9, 3 on the original, I'm going all the way over here to -9 because I've reflected. Right 1, 1, 2, up 3. Puts me there. Let's see if those points work out. The points should be 1, 3, 0, 4, -3, 5, and it should be -8, 6. I'll let you double check to see that these points work inside this new function. And it's probably good to factor out a negative sign if both of those are kind of convoluted. It's good to have the x all by itself and be just an x and not have a negative sign with it. Okay, last one, this piecewise function, which piecewise just means it's kind of a funky looking one that's not like the original 6 apparent functions that we know. Tease out what's happening here. We're reflecting over the x-axis, right 2, up 1. So I have just replaced these in the dotted line here, or the dotted sequence. I've got my original points. I'm going to do those 3 in order. Reflect over x, right 2, up 1. So I reflect over x. This one comes down here. And right 2 and up 1. There's a big point. I'm going to erase my work here. Oh no! Erase my work there. Each one also goes reflect over x, right 2, up 1. Reflect over x, right 2, up 1. I'm on to this point here, this kind of this flat edge. Reflect over x, right 2, up 1. Takes me there. And now this last point, this one, these are kind of your anchor points or your important points, the ones that will help you frame it. I'm reflecting over x. That puts me way up here. Right 2 and up 1. Here is my new function that has been reflected over x, right 2, up 1. I think it's okay not to erase your sloppy copy there because it does help you kind of see what's happening.